Everybody, Mr. Seymour here. Welcome to week 3. We're going to start on a different disorder this week, and it's the disorder of something you can see in front of you, which is disorders of the eye. The main function of your eye is to be able to see, to be able to focus on the world around us in a visual way. The disorders, therefore, are points and structures of the eye that don't allow that to occur. As you can see here, do you recognize anything on that screen on the left-hand side? Well, it's an example of one that you see at the optometrist. So have you ever been there? Have you ever been to one of those appointments and had your eyes tested? Maybe you have, maybe you haven't, maybe you've gone through that process and you are well versed every couple of months with getting your eyes checked. I know my family definitely are. Me, I'm not, but my girls and my wife definitely do. So today is all about the disorders of the eye and therefore what is wrong with the eye, especially structurally, in order for those disorders to occur, and therefore how can you treat those disorders. Right, so first, let's go into kind of a Year 9 version of parts of the eye. So firstly, we've got this outer area. You're going to go into these websites quite in a bit of detail during Blitzing Bio pages, but I'll just quickly do an overview. So you've got your conjunctiva, which is just the viscous, very gel-like substance that's on the outside of your eye, in order for things to be caught in it and just keep the eye nice and moist. And conjunctivitis comes from the having your conjunctiva have an irritation to conjunctiva. You then have your cornea, and your cornea is your first port of call, where the light coming into your eye is refracted, not reflected, just like a mirror, refracted, which is bending of light rather than having light come back on itself. It's the bending of light as it comes from one media to the other. So this is coming from the medium of air into the medium of a solid, which is your cornea. So it kind of bends just a little bit. And then we've got this area here, which is the aqueous humor, which is just a watery substance that keeps this nice and plump, and it doesn't flop back on itself. So this is called an area where there's kind of watery substance called aqueous humor. Then in this part here, you've got your iris, and the iris is obviously what your color of your eyes are. I've got blue eyes because my iris is blue, and that iris actually moves in and out because it's a muscle, and that iris decreases and increases the amount of light that comes into your eye. Obviously, if you're going out into really sunny light, this iris decreases the amount of light. The pupil, which is the hole in between the iris, decreases that hole in order to allow less light to come into your inner part of your eye. If it's very dark, then it'll open up and it'll relax a bit in order for the iris to open up and that pupil to be bigger. Then we've got our lens. Now this is the main refractive component of your eye, and it will refract or bend that light as well as it possibly can, because it doesn't move itself. It has to be moved on its own to be able to bend that light more or less, depending on what you want to focus on, near or far away. So in order to bend that light, it's got to have a muscle attached to it. So here's the muscles up here and down here, but it's got to have, muscles don't connect directly onto the lens. It's got to have a ligament, and here's it shouldn't be red. These ligaments are kind of not really that red, but these are suspensory ligaments, suspensory ligaments attached to these ciliary bodies, they're called, or muscles, ciliary bodies that will pull and make this lens thinner, and you'll see in a minute why that's really important. Then we've got the inner part of your eye, which is held open by this very viscous, very gel-like fluid, which is vitreous humor, And then at the back of the eye, obviously light comes in and it wants to be focused perfectly, because that's what we want of the eye, focused perfectly of the world around us onto the back of your eye. And this kind of pink bit should be representative of your retina. It's kind of here, but that's not where the retina is. It's kind of right on that edge here and all the way around. Not this bit, your retina is not there. So that's your retina. You've got this area here of the retina, which is a concentration, lots and lots of photoreceptors here. Retina is made up of photoreceptors, but there's heaps of them in kind of this area here, and that's called the macula. And if you've heard macular degeneration, that's where most of what you see in the world actually is focused on this point around there. And if those photoreceptors, rods and cones, they're called photoreceptors, if they're starting to fail, it's called macular degeneration. When you look into someone's eye, you can see kind of this space here, but also you can see the white mostly around their eye, and that white is called the sclera, and that's kind of a tough, hardy outer layer as well. When the photoreceptors have done their job, made up of the retina, then it will send electrochemical signals and the pathway through this optic nerve that you see here. So that's a quick rundown of the parts of the eye. You can actually go and click on here when you get into it, and it will take you through a lot more detail than that. All right, the next part, this is not what you're going to look at today, but I'm going to run you through how your eye actually focuses, all right, because this is super helpful. You can sign up, I think, for Gizmo and get this on your own, but as a teacher, I signed up to this just for a trial period. At the moment, we want to be looking at this apple, okay? And this is what your eye is doing when looking at this apple, and obviously you need light to make your eye be able to see something, so that's why they've got this light here. So we've got two things happening here. We've got this light beams coming in. That's the red that you see here. And that's got a thing called a focal point. And physicists, physics people might know that, focal points move. And that's where the light rays actually swap over and come to a single point, just a relative point in space. But here also they've got kind of a point of focus. So this is called the focal point, but for this example, they've got a point of focus to say, if I want to see this bit of the apple, then it should be focused on this bit of the retina back here. But normally what you would find in physics, and you'd say, well, the focal point is here, so you can see the entire apple. All right, so this is what you normally see, the red, but we've made it a bit easy by having this white thing here, which is where it is focused. So what do we do? Well, we want to see this apple. At the moment, it's pretty well focused. Let's get it out of focus for now. Let's do something to get it out of focus. That is not well focused, is it? So we have to do something in order, if you want your eye to see that, your eye has to do something, and you could move closer to that or just move around further back and focus that way and move your actual entire head or your body. But your lens can go thinner and be pulled thinner, as we remember, pulled thinner by these ciliary bodies, or these muscles called ciliary bodies here, and the suspensory ligaments, and pull this lens thinner in order for you to be able to see. So can you see roundness of lens? We've got a distance here, and it's relatively close. What do we do in order to see? All right, beautiful. So it was back here, wasn't it? So we have to pull out in order to be able to see that well. All right, so we're doing a thing called accommodation or accommodating. That lens is being pulled out and thinned out in order to be able to see. So the focal point here, it was there. We've moved it back a little bit. All right, so the focal point's moved. You can see moving back. We've only moved it back just a little bit. All right, so the focal point's moved back, and the lens has gotten thinner in order for us to be able to see. And if you can't do that, then there's a disorder that doesn't allow you to do that. So that's close up. Let's see if we move this a long way away. All right, so I'm going to get rid of this. So there's our apple. I'm going to move it a really long way away. All right. Okay, so that's a long way away. It's out of our shot, all right? So what do we actually have to do in order to see this again? Because at the moment, it's really bad. So again, we have to move this lens and accommodate for that change. So here, what do we do? So we're just making nice and thin, and moving that focal point. It was here. See where that focal point is going? Focal point was here. Moving the focal point further into the eye to be able to see it. Now it's a long way away, and now it's perfectly, and we can see it really well without it being blurry. All right, so that's how it should work. What happens when it doesn't? All right, so here's the next bit. So we've got 3 disorders here that we're going to have a look at. Here's healthy. So here's when it's healthy. We've got our apple again, and as you can tell, rays of light are coming in. They're being refracted through the cornea, then refracted again through the lens mostly, and then here's our focal point, and then here's a nice kind of little apple. Interestingly, upside down. It's reversed and upside down. All right, and your body, your brain actually turns it back around the right way. But that's a side point. But that's the way it normally should work. And you know, the macula, which is just above this optic nerve coming down here. But what happens if it doesn't? Well, there's a few issues here. Firstly, we've got a thing called astigmatism. And this happens when your cornea or your lens aren't perfectly nice and symmetrical or rounded correctly. So maybe one is a bit thinner and one's a bit fatter, your cornea. Or here, your lens, it isn't nice and rounded, nicely rounded on both sides. It might be thinner here, it might be thicker or fatter on that side. So it kind of does this. Fat and then a little bit kind of thin here and goes flatter, you know, nicely curved there and then flat on that side. And if it's curved on one side, it should be curved at an equal angle on the other side as well. So if it isn't, and if it isn't symmetrical, that curve, then it will have an apple kind of there and also a little bit lower. Can you see that? It's kind of doesn't look like an apple anymore. It looks like kind of a skewed, weird, pulled out apple. All right. So astigmatism is when you have areas of the cornea or the lens especially that is not symmetrical, and then you've got these points where there's an apple and there's another apple and there's another apple. In order to change that, accommodate for that, you get glasses, and those lenses specifically are angled and curved in order to refract the light, the rays of light coming in at specific angles in order to accommodate for those differences. And if it's thinner on one side, it'll be fatter on that side, etc. So see, it's fatter and then thinner, or curved, very flat here and then curved a little bit more here, because it's the opposite here. It's kind of really curved there or not as much there. All right, so that's astigmatism. Now, these other two, you might kind of notice a little bit easier, myopia and hyperopia. So myopia, that is, some of you might already have that or have friends who have that. This is nearsightedness. Now, this means myopia. Nearsightedness means you can see when things are close up, like a book, all right? The problem, the disorder of myopia, is you can't see far away. So even though this looks near, this to be myopia, this apple is a little bit further away. And due to this lens, and this is the problem, all right, it's not that the apple's the problem, it's your lens or your cornea or the length of your whole eye is either too long, or the curvature of your lens is not enough. All right, so it's just it needs to be thinned out a little bit, and it's quite thick. All right, so either that's really thick and it's bending too much. Can you see it's kind of bending way too much? Or you just have an eye that's too long. You know, the way that God's made you, for some strange reason, your eye is just too wide there. Both reasons, either the lens is too thick or the length of your eye is too long, causes the focal length to not be in the right position. It should be, as you can see over here, it should be in the middle, and it's a little bit too far to the front. So what do? Well, we have a cave lens here and a cave lens here called a concave lens. Concave lenses in your glasses are given to you by your optometrist in order to change the angle of these light beams coming into your cornea and therefore into your lens in order to move the focal length further into your eye in order to focus that lovely little apple on the correct part of your retina or your macula. So that's myopia. Nearsightedness. Nearsightedness is corrected by concave lenses. That's a big summary. As you can see here, hyperopia is the opposite of that. If myopia is nearsighted, then hyperopia is far-sighted. Now that means that you can see far things that are far away. The problem with hyperopia is you can't see things close up like a book. So here again, why do we have hyperopia? Why can't we read a book? Well, for some reason, you might have been born with an eye that is not long enough. Too long, myopia, too short or too thin of an eye, and it's called hyperopia. So the actual focal point is too far into your eye, and so the point at which you can see that apple well is kind of at a virtual point somewhere inside your brain a little bit, and that, well, obviously you can't say that. You can see a blurry point because that retina there is the only point at which your photoreceptors can sense light. It can't sense it anywhere back there, so it only senses the light rays coming in here, and therefore photoreceptors go off at that point, which is not appropriate and it's not focused. So what can we do? Oh, what are the issues, therefore? Well, like I said here, the lens is too fat here. Here the lens is too thin, all right? Lens is too thin, or you don't have your whole eye is just not long enough. How do we correct to that? Well, hyperopia, farsightedness. How do we correct it? Convex lens. Hyperopia, farsightedness, convex lens. There is one more called presbyopia. Presbyopia is where if you get older and you're trying to your lens is trying to accommodate or kind of be pulled out, stretched out by the ciliary muscles, and it can't do that, or it can't go back to a nice round shape as well when it needs to be able to see close up, then that's called presbyopia, because over time the cells inside your lens don't start to get really crystalline and start to be nice and be really quite solid. And instead of like a balloon, your lens can kind of be pushed and pulled really well. It gets really tough and hard, so it doesn't kind of pull back and be nice as well as it probably should. All right, so they're the problems today. You'll be kind of exploring all those ideas through a few of these things. So you'll be looking at a few of the things I showed you before, but then you're going to watch this hopefully for a little while, this cow eye dissection, which is a bit of fun. So watch that video. And then you'll be using this how your eye works. So this is kind of like, I'll go out. This is going from the front and then kind of delving into your eye. And again, looking at the sclera and a few other things in your iris and the pupil, which is actually nothing. Your pupil, it's a structure without being a structure, all right? And your iris, so you'll look through that as well just to get that kind of inward view. And this one here again will go through near and farsighted and stigmatism and presbyopia. Sorry the videos don't work in these ones, but it will kind of take you through what things look like normally. And as you can see here, can you see it will actually show you those what eyes look like and what occurs, what normally will be with nearsighted people versus normal people, and just to explain what I had a look at before. And then you'll be looking at another correction, a newer kind of 20-year-old correction, which is called LASIK eye surgery, or you can see the kind of extended name of that there. And this guy will take you through what LASIK is all about. My wife actually had LASIK, what was it, a good 15 years ago or so, and she used to have considerably tough, she couldn't see very well, and she had LASIK eye surgery, and she's been without glasses. I think it was up only till a few years ago she could work without any glasses, which is, you know, phenomenal with where she was at. So LASIK eye surgery is a really good treatment that's only been around for, well, it's about the 1990s now, so, you know, 30 years or so. All right, hope that makes sense. I know it's a kind of short/long summary of what we've been doing today, but hopefully that gives you a way in. If you want to review what we've done today, or if you weren't there for today, this will give you a bit of a catch up. All right, good luck.